The moment the conversation started about Starship production, the numbers sounded insane. Elon Musk said they could reach 10,000 ships per year. 10,000, that is not a typo. Think about that for a second. Most rocket companies can barely launch a handful each year. SpaceX is not just talking. They have built a massive facility called the Gigabay at Starbase. It stretches 700,000 square feet. It was designed to churn out rockets like cars on an assembly line. You see where this is going. If they hit even a fraction of that goal, it changes everything in space transport. Every detail matters when you are talking about thousands of massive rockets stacking up on launch pads. The engineers started with a problem nobody else could solve. Rockets are heavy, expensive, and fragile. Each one takes months to build. Boeing tried conventional methods. NASA stuck to their old designs. They both struggled to hit double-digit launches per year. Costs ballooned and schedules slipped, but SpaceX saw differently. They treated each rocket as a product, not a one-off experiment. That meant designing parts for repeatability. Steel for the tanks is stainless and lightweight. It was built for speed and reliability. Then they rethought assembly. Instead of shipping pieces across the country, everything came to one massive haul. The result was faster, safer, and cheaper builds. They did not just build one rocket faster, they built the production line like an entire factory for thousands. Robotics handled welding in minutes that took humans days. Engines, the Raptor series, were made on site with precise machining. This cut error margins to almost zero. The tank section could be stacked, inspected, and moved in hours. You have felt that frustration with any project at work when you are waiting on parts or delays. They eliminated it. The team worked in shifts around the clock. By the end of the year, they had dozens of ships ready for testing. That is months ahead of the old aerospace schedules. Starship burns methane and oxygen. This fuel is cheap and reusable, but tricky to store and pump fast enough. The engineers built gigantic fuel tanks at the pad. Pumps could move millions of liters quickly. They tested pressure limits repeatedly. Failure here could mean a disaster at liftoff. One test saw a leak 30 seconds from ignition. They fixed it immediately. This cycle of failure, fix, and scale is what separates a lab experiment from an industrial machine. The competitive edge is obvious when you see the numbers. SpaceX aims for hundreds of launches a year, while China managed 100. Blue Origin is still under 10. Boeing's Starliner has not reached regular flight yet. Musk's projection of 10,000 Starships is not a fantasy. It is a roadmap. Every launch adds experience, data, and confidence. You could almost measure the hierarchy with SpaceX at the top. They are learning fast while the rest struggle with bureaucracy. That scoreboard determines who will dominate space commerce. Reusability is key. Every booster and ship is designed to land back on Earth, be refurbished, and launch again. Early attempts failed spectacularly. One booster tipped over and engines ripped apart. The team studied the physics meticulously. Grid fins were redesigned, landing legs were reinforced, and software was rewritten. Landing a 230-foot rocket safely became routine. By the next launch, they were catching boosters in a controlled descent. This saved millions each flight. Production efficiency is now staggering. The Gigabay alone can handle hundreds of components in parallel. Engines, tanks, and nose cones are all integrated within one workflow. The timeline for each Starship dropped from 6 months to just weeks. Moving a fully assembled ship is not trivial. They developed specialized transporters and synchronized cranes. Engineers simulated every movement digitally before touching metal. That level of detail ensures safety and speed. SpaceX is not just building rockets, they are building a fleet. Mars colonization requires thousands, not dozens. If they hit a production rate of 10,000 ships annually, they can deliver cargo at a fraction of today's cost. China and other competitors will struggle to keep up. The knowledge compounding here is crucial. Each ship built teaches engineers something new. There is a feedback loop most companies only dream of. It is not just about building the ships, but how fast you can launch them. Every day a Starship is ready, you can collect data and refine the design. The faster the launch rate, the more learning occurs. Elon's numbers suggest an industrial rhythm unheard of in aerospace. Hundreds or thousands of launches a year create a new era in orbital logistics. The competitive edge is exponential. The Raptor 3 has a throttle range and efficiency that surpass older engines. It uses methane, which is cleaner than kerosene. Each engine produces 500,000 pounds of thrust. That is enough to lift a fully loaded Starship. Imagine lining up 10,000 of those engines a year. The result is a system where failure is anticipated and minimized. Each reusable ship reduces per-launch costs drastically. Reusability brings it down by at least half. SpaceX reinvests every saving into production improvements. They are transforming the economics of space itself. If Boeing or NASA tried this, they would face years of planning and red tape. SpaceX bypasses all of it with speed and scale. Engineers have synchronized launch procedures and fueling for rapid cycles. One ship experienced a valve issue 30 seconds from liftoff, but the team corrected it without delay. The entire facility could produce another ship while troubleshooting. This level of planning is rare in aerospace history. When competitors see one Starship launch, SpaceX is already planning the next. Projected 10,000 ships per year is a logical extension of their capabilities. Every successful landing validates designs. Competitors watch, but catching up requires culture and speed. SpaceX has both. You can see it in the launch cadence and cost metrics. Pattern recognition shows the growth trajectory. Production numbers tell the story. One test ship became dozens, each built faster and safer. Boeing still tests one vehicle over months, while NASA relies on contractors spread across the country. SpaceX concentrates everything under one roof. This compresses timelines and increases reliability. Elon Musk's insistence on vertical integration ensured problems were solved on site. Engineers did not wait for external approvals. Decisions were made by the people building the rockets. That ownership accelerates problem solving. China's rockets are strong, but production is slower. Blue Origin still experiments with small flights. SpaceX's industrial approach gives them leverage. They are building the future of accessible space transport. Reusability works, massive scale production works, integrated assembly works. The strategy compounds as more ships mean more launches and more learning. Low Earth orbit is now routine. Moon missions can scale. Mars colonization is no longer a dream. SpaceX shows that combining technical innovation and supply chain control creates transformation. The competitive scoreboard proves it. They solved engine stress, heat shield survival, and mass production. Competitors lag behind in launches and production scale. Reusability reduces waste and increases speed. Supply chain mastery ensures nothing stalls progress. Each failure teaches, and each test accelerates. That is how 10,000 rockets a year become possible. When you look at the sky, these massive rockets are the future. The work today unlocks Mars tomorrow. Technical mastery plus operational efficiency equals transformation. SpaceX just proved it can be done. The Starbase site stretches wide with steel hulls glinting under the sun. 10 hulls stand in different stages. They are stacking faster and welding seams without pause. One ship used to take months to finish. Now crews finish them in 15 to 20 days. The cadence is climbing toward one ship per month ready for flight. Each ship has 230,000 pounds of thrust per engine. 3 of them together push 690,000 pounds. That is enough to lift 100 tons of cargo. The engineering team perfected fuel flow and cooling systems step by step. Each improvement shaved days off the production cycle. The stainless steel hull is a precision instrument. Booster 19 took 23 days from first weld to full stack. That is half the time of the previous one. A misalignment can create weak points at Mach 3 speeds. Precision matters as much as speed. Flight 11 roar was heard for miles. It used 5 million pounds of combined thrust. The booster touched down within 35 meters of the target. Recovery took navigation adjustments in the final 30 seconds. Exacting control makes rapid reuse possible. One ship finishes, and another rolls out. Engine integration is the main limiter. Hundreds of tiny valves must be installed precisely. One failure in January delayed a ship by 3 days. The team caught a sensor misreading pressure in time. The system is designed to fail safely. Boosters require heat shield tiles fitted individually. Attention to detail is why only 1 to 1.5 ships leave monthly. Any mistake could cost millions. Gigabay expansion is the future promise. 2 new buildings over 700,000 square feet are under construction. Each bay could produce dozens of hulls per month. SpaceX projects capacity in 2027 at about 1,000 ships a year. Right now, crews still work outside under sun and wind. Weekly milestones are maintained even without the full facility. Short-term goals aim for 1 flight-ready ship per month by mid-2026. Thousands of parts must arrive in sync. SpaceX built warehouses to allow on-demand delivery. One delivery mistake in December caused a temporary hold. Coordination is like running 3 grocery stores at the same time. When one piece is missing, the entire stack halts. The system adapts quickly. NASA's SLS rocket took over 6 years to assemble a single vehicle. Cost per launch ran over $4 billion. SpaceX assembles Starship in weeks with costs under $100 million. Nobody else matches the numbers yet. Every test flight collects massive data sets. Any deviation triggers adjustments. Flight 10 had a near miss 30 seconds from launch. Engineers adjusted the next booster's settings, and it flew without issue. Iterative learning accelerates pace without compromising safety. Failure is converted into lessons faster than anyone else. The grid-fin system makes landings repeatable. Recovering boosters reliably accelerates the program. The upper stage engines use a cross-feed system. Fuel is balanced during flight. One engine can underperform while others compensate. The booster has 33 Raptors with 7.7 million pounds of thrust, enough to lift a battleship. Every flight gives insight and refines hardware. Technical mastery turns into competitive dominance. One Starship every 2 weeks is a new reality. Competitive scoreboard is clear. By mid-2026, 15 to 20 flights are expected annually. That scale and reliability confirms SpaceX's place in history. It is not hype, it is quantifiable. Output could jump to dozens per month once gigabays are online. This creates a pipeline for lunar missions and Mars cargo. Costs drop further as mastery compounds. The Gigabay towers over everything at 380 feet. It holds 24 dedicated work cells. Cranes lift up to 400 tons. One slip is a multi-million-dollar disaster. Everything happens under one roof, fast and precise. Steel columns reach 3 levels by January. Sections move without trucks or cranes outside. Traditional rocket assembly is slow and fragmented. NASA and Boeing have tried bigger facilities, but bottlenecks remain. SpaceX needed to rethink how pieces moved. They went vertical with elevated platforms. It is a giant chessboard where every piece moves exactly where it should. One misaligned ring can fail a ship. One lift in November nearly dropped a booster section. 30 seconds from disaster, they corrected it. Each specialized cell focuses on welding or stacking. Top floors host meetings close to the action. Decisions happen faster. A booster that took 2 months now moves through in weeks. 1,000 ships a year is about 83 per month. Florida Gigabay fills the gap toward 10,000 annually. Workflow is almost robotic in precision. Efficiency drives dominance. Integration includes testing in real time. A Raptor engine installed passes alignment tests immediately. Every minute saved adds to yearly output. Consequence tracking and technical control are applied at scale. Speed is multiplied by accuracy. 10,000 ships start looking real. The dream of thousands of ships a year stops being just talk. It becomes reality. Building 10,000 starships a year sounds like a dream. Elon Musk wants 27 starships every single day. They needed robotics and modular jigs. System cuts time, mistakes, and headcount. Starship 5 took 2 months, but Starship 15 had sections done in 3 days. Precision needed for Raptor engines is intense. Automated valve testing and fuel pump calibration were used. One pump was adjusted within 30 seconds of an error. QR codes and sensors track each part. 0 wasted steps. Florida handles forward sections while Texas builds aft sections. Dual site strategy reduces bottlenecks. One reflight saves millions. Recovery and turnaround times are critical. Heat shield tiles broke at Mach 6. Engineers redesigned the tiles and survived the plasma phase. Modular system allows for quick swaps of satellites or cargo. Automated system corrected a lunar module misalignment within 30 seconds. SpaceX can launch 27 ships a day if automation holds. Boeing still struggles with 337 backlogs. SpaceX's scale is a real differentiator. Welders and engineers work in perfect sequence. Bottlenecks are identified and removed. Launch revenue and Starlink income are reinvested. Dollar goes to systems that improve speed or safety. Custom transporters carry entire sections without disassembly. One transporter sensors prevented a collision 30 seconds before impact. Technical mastery turns impossible speeds into achievable outputs. Insights from Starship 12 cut assembly errors by half. Fueling and igniting are done under tight timing. One test anomaly was corrected by valves 30 seconds before liftoff. Each new ship is a step toward Mars. Operational mastery will be unmatched. Decisions happen in hours, not months. Human-machine synergy is rare. Forward, mid, and aft sections fit like Lego. Anomaly during testing saw sensors activate corrective welding within 30 seconds. 10,000 starships moves from dream to potential reality. Each failure becomes a lesson. Achievement is validated in numbers. Technical mastery, competitive insight, and relentless execution make this possible. SpaceX's Starship program is the benchmark. They solved engine stress and heat shield survival. Reusability reduces waste. Supply chain mastery ensures nothing stalls. 10,000 rockets a year is the future. The impossible is becoming inevitable. Steel, fuel, and precision all combined. By 2050, 1 million people could live on Mars. The engines work, the ships fly, and humanity takes the next step. SpaceX proved that mastery and scale make the impossible possible. SpaceX has transformed space travel into a fast and industrial process by using massive factories and reusable steel rockets. They have proven that they can build ships in weeks and launch them at a fraction of the cost of traditional programs. This mastery of production and reusability clears the path for regular missions to the Moon and Mars.